Welcome to section 6.5, and what we are dealing with in 6.5 are properties of logarithms, and so that's one of the first things that I need to give you. There are four main ones, and since logarithms are just really funny looking exponents, they fall right in line with the laws of exponents as well. At least three of them do. The first one is the power rule. If we have log of a to the n, and this works for any base whatsoever. It can be base b, it can be base 8, it can be base e, a common logarithm of base 10, whatever. Either one will work. What we can do is we can take this exponent and move it out in front, and so that it becomes n times the log of a. And this does simplify some problems quite a bit, especially if you know what the logarithm of a is. So that's the power rule. If we have the logarithm of two numbers multiplied together, then much like the exponents, what we do is we take each of those individual logarithms and add them together. Likewise, if we have a quotient, the log of a over b, that would be the log of a minus the log of b. And so here are the three main properties of logarithms, but there's also a change of base, which allows us to use the calculator to find values, because our calculators are pretty limited. Most calculators only have logarithm, common logs, and natural logs. And suppose we wanted log base 3 or something like that. Well, there is a way to do that, and that is to put it into this formula. Suppose we have log base b of some number m. Then what we're going to do is we're going to take the log of m over the log of b, and that will give us what log base b of m is. Now this log here, since this is going to be using the calculator, this can either be the common log, log, or it could be the natural log, ln. So either one will work. So with that in mind, let's start working on our examples. It says use the properties of logarithms to find the exact value of the expression. Okay, so we have natural log of e to the third and basically we can put this exponent out in front, so it's 3 times the natural log of e. Now here, since natural log is log base e, and we want to know what's the natural log of e, that is 1. So this is 3 times 1, which equals 3. So that one's pretty simple. And non-mathematical way to think of it, the natural log and the e here sort of cancel each other out, and that leaves the 3. But that's not entirely true, so you do need to be very careful with that. Okay, number 2, we get log base 6 of 13 times log base 13 of 216. Let's see, what can we do here? We can't really find anything that's helping here, but we might be able to split this up. I bet if we check 216, I bet 13 will go into that, and in fact, let's see, 10 and 86. Let me check real quick to see if 216 or 13 goes into 216 evenly. No, it doesn't. So basically, there's the exact value. There's no way we can simplify this because we can't change 13 into a power of 6. We can't change 216 into a power of 13. So this is pretty much as far as we can go. Why they necessarily put this problem here, I'm not really sure. I think what might have wanted to be done, we might have wanted to put 13 over here and 216 over here. Then it would be much easier to deal with at that point in time. So we'll just say that is the final answer, and because that is indeed the final answer. Now, number 3, we are asked to find what is the natural log of 8. But that is using the fact that natural log of 2 is a, and the natural log of 5 is b. So the first thing we want to do is we want to use the properties of logarithms to write each logarithm in terms of a and b. In other words, in terms of 2's and 5's. And so if I look at this, I realize that, hey, 8 is really 2 to the 3rd power. So I put it in terms of 2. But I know that I can bring this exponent out front, so this becomes 3, the natural log of 2. And according to the problem, the natural log of 2 is equal to a. And so this would become 3a. Continuing, we've got a set of 4 problems that says write as the sum and or the difference of logarithms and express powers as factors. In other words, use all 3 of the properties to simplify this, get rid of as much mayhem or confusion as possible. So we have the log base 4 of x squared over y to the 6th. Now the first thing we need to do is get rid of this quotient. So that would be log base 4 of x squared minus log base 4 of y to the 6th. Now each of these exponents can go out to the front. So this would equal 2 log base 4 of x minus 6 log base 4 of y. And basically, in these problems, we're looking at, we want to have simple logarithms, logarithm of x, not the logarithm of x times 5 or y times 2. And so these are the simplest logarithms that we're going to be able to get. So there is our final answer. Number 5, we have log base 3 of the square root of x over 9. And so we can rewrite this, first of all, using the quotient rule, log base 3 of the square root of x minus log base 3 of 9. Now, first thing I'm going to deal with is this. This can be written, square root of x means x to the 1/2. So I can rewrite that as log base 3 of x to the 1/2 power. Likewise, if I look at this problem, I see 9 is a power of 3, so I can rewrite it in that fashion, 3 squared. Now each one of these I can bring the exponent out front, so I get 1/2 log base 3 of x minus 2 log base 3 of 3. Now this one won't simplify any further because we don't know exactly what x is, so this is going to still remain 1/2 log base 3 of x. But if we look at this one, log base 3 of 3 is 1. And so this becomes 2 times 1, or 2. And there is what we get, is our final answer, 1/2 log base 3 of x minus 2. I guess that's another property. If you have log base a of a, that always equals 1. Just to keep you apprised of that particular function. Okay, number 6. Number 6, we have log base 5 of quite a mess. It is the 8th root of m times the cubed root of n all over k squared. And so what we first of all need to do is get rid of this product and this quotient. So it's going to be log base 5 of the 8th root of m plus log base 5 of the cubed root of n minus log base 5 of k squared. Okay, in this one, the 8th root of m is m to the 1/8 power. Cubed root of n would be m to the 1/3 power. And here I can go ahead and bring this 2 out front, so we get 2 log base 5 of k. Now log base 5 of k, we can't go any further, so this term is going to remain just like that. This one we can take the exponent out front, so we get 1/8 log base 5 of m, and we look, log base 5 of m won't go any further, so that's as far as that one's going to go. Plus, bring the exponent out here in front, 1/3 log base 5 of n. This one won't go any further because log base 5 of n just won't simplify any further. And we've already said that this term is not going to go anywhere. So each of these individual terms aren't going to go anywhere. They aren't alike, so we can't combine them. So therefore, there is our final answer. And then the final problem in this section is number 7. And we are taking the natural log, which we need to realize is log base e, but there's just a little bit simpler way to write it. And that's 9x to the 7th power times the square root of 1 plus 5x all over x minus 6 raised to the 5th power. So the first thing I need to do is take the natural log of this plus the natural log of this minus the natural log of this. So let's see what we get here. Get the natural log of 9x to the 7th plus the natural log of the square root of 1 plus 5x plus minus, that should be a minus the natural log of x minus 6 raised to the 5th power. Okay, following the same rules, we can take the 7 and bring that out front. So we get the 7 natural log of 9x. Now, we ask ourselves, are we done with this? No, because now what we have is we have a product. We need to get rid of that product. So we'll do that here shortly. Then we get the natural log of, well, this can be rewritten as 1 plus 5x raised to the 1/2 power. Minus, okay, I can now bring this 5 out front, 5 natural log of x minus 6. Okay, now look at this. Can I change this to natural log of x minus natural log of 6? The answer is no, because what allows me to do a natural log minus a natural log is the quotient. This part of it, the minus the natural log. This is what allows me to take a natural log minus a natural log. So this one is as far as this one will go. But this one we can separate a little bit more. So we're going to get 7 times, splitting this up would be the natural log of 9 plus the natural log of x plus. Okay, this middle term here, I can take the 1/2, bring it out in front. So we'll get 1/2 times the natural log of 1 plus 5x. Now let's look at this. Can I simplify this any further? Can I do natural log of 1 plus natural log of 5x? Once again, the answer to that is no, because the only thing that allows me to add 2 natural logs is when I'm actually multiplying in the argument here. So we are almost finished. There's only one more thing left to do, and that is we can now distribute this 7 to both the natural log of 9 and the natural log of x. So it becomes 7 natural log of 9 plus 7 natural log of x plus 1/2 natural log of 1 plus 5x minus 5 times the natural log of x minus 6. Quite a bit, but it works. Now examples 8 and 9 are the exact opposites of what we just got done doing with 4 and 7. 4 and 7 we're splitting everything up. 8 and 9, what we're actually asking to do is put it all into one logarithm. So let's see how we can go about doing that. Number 8 is log base a of 5 plus log base a of x cubed minus 2 plus log base a of 3. Now we look at this, log base a, log base a, log base a, and we're adding. So what we're going to do when we really combine these all together is we're going to end up with 1 log base a, but since we're adding, what we're going to be doing is actually multiplying these arguments, 5, x cubed minus 2, and 3. So I'm going to multiply 5 times x cubed minus 2 times 3. And we are going to go ahead and do the multiplication. Well, the easy way, 5 times 3 is 15, and 15 distributed here would be 15 x cubed minus 30. And so, final answer would be log base a of 15x cubed minus 30. Number 9 asks us to do the same thing, but we do throw in a few other things here. 4 log base 3 of 2 plus 1/4 log base 3 of x minus 2 minus 1/2 log base 3 of x. Okay, now the first thing we have to realize is since we have these coefficients out here in front, we can now send those back to become exponents. So this becomes log base 3 of 2 to the 4th power plus this becomes log base 3 of x minus 2 raised to the 1/4 power minus log base 3 of x to the 1/2 power. Now we know 2 to the 4th is 16, so this becomes log base 3 of 16. Anything to the 1/4 power is really the 4th root, so this becomes log base 3 of the 4th root of x minus 2. And anything to the 1/2 power is the square root, so this becomes log base 3 of the square root of x. Now we finally deal with the pluses and minuses. We need to remember that the pluses means they're multiplied and the minus means they're divided. So we've got our 3 logarithms, but now it's time to combine them into one. Log base 3 of, okay, this is going to be 16 times the 4th root of x minus 2 all over the square root of x. And there is our single logarithm. Number 10 and 11 asks us to use the change of base formula to find values. And both of these we are asked to round to 3 decimal places or 2 decimal places, depending on which problem. So we're going to be using our calculator. And so before we go there, let's just remind ourselves of what we have. Suppose we have log base 5.6 and realize that's perfectly legitimate. You can have any base whatsoever here. If you want negative, you can have negative even. Log base 5.6 of 231, well, the change of base says take the log of the argument, 231, over the log of the base, 5.6. So that's all we have to do here. So I can go to my calculator, clear out anything that I've done, and let's see, I want the logarithm of 231, close that out, and then I'm going to divide by the logarithm, or the log, of 5.6. Close that out, and then hit enter, and I see that's 3.1591, but we only have to round to 3 decimal places, so it's 3.159. Back up to here where I need to be. So this equals approximately 3.159. Number 11 is very similar. About the only thing that's different is that we're going to round our answers to 2 decimal places instead of 3. So what we have is log base 2/3, which is perfectly legitimate, of 19. Now this time, just to be a little bit different, I'm going to take the natural log. But it works, natural log or logarithm. But make sure if you choose natural log up here, you choose natural log down here. That's the only thing you have to do. So we're going to take the natural log of the argument, which is 19, over the natural log of the base, which is 2/3. And so using our calculator, in this time use natural log instead, it doesn't really matter. I just want to change things up. So we're going to have the log of 19 divided by the log, or natural log, of 2/3. And so do 2 divided by 3, because that's the easy way to put 2/3 into a calculator. Hit enter, and round to 2 decimal places, we get negative 7.26. And there is the approximate answer for number 11.